Hello guys, I am Jidugu Sriharisesh and today I am going to demonstrate an experiment to you. This experiment is about thermal expansion and heat. Now, the materials I have used are 2 wax candles, 3 balloons, and out of the 3, 2 have air filled in it. Now, let's first demonstrate the experiment to you and then I will explain you the concept. So, now I am going to place this above the fire. Take precaution and be safe when you do this at home. Now that balloon burst. Now let's see if this balloon also burst. This also has air in it. It burst again. Now both the balloons have burst. Now let's see if this water balloon also bursts. Now you would be wondering why those 2 balloons have bursted. Your analogy may be due to the expansion of the rubber. It has bursted. Now let's see with this one. I am placing it above it. As you can see, nothing happens to it. It didn't burst in the same time. This is because the rubber was not the cause of the bursting of balloon. It was the air inside it. Now let's understand this. Let's understand the concept behind this. The concept behind this is the thermal expansion of air and the thermal expansion of water. Air has a high coefficient of thermal expansion and thus with increase in temperature, the volume and pressure increases and thus the balloon bursts. But water has a low value of thermal expansion coefficient and thus the balloon with water didn't burst. And this is the logic why the 2 balloons earlier filled with air bursted and this didn't. Another analogy to this may be that the ideal gas equation PV is equal to nRT, where P and V are pressure and volume respectively, N is the moles, R is the ideal gas constant and T is the temperature. With constant moles of air inside it, which I had in those balloons, I didn't put more air inside it. R is constant, thus when temperature is increased, P and the product of P and V also increases. And thus when P and V increases, the volume expands, the volume increases, the balloon expands, the volume increases, and thus the pressure also increases, and thus the balloon bursts. But in this case, the rate of change of PV with respect to time, with temperature, the product didn't increase rapidly, and thus this balloon didn't burst. Thank you.